Hello and welcome back to, I think it's the 5th speedrun of today. And in this speedrun, we're going to be covering partial fractions. So if you were following along my previous speedruns, you'll remember that in the chapter 1 review, we came across a very nasty partial fraction question. And I was very surprised that it was there because we haven't covered partial fractions yet. But now we're getting to them. So what is a partial fraction? A partial fraction, decomposing a fraction into partial fractions is when we have a rational fraction, say like 1 plus x over 1 plus x squared. Actually, that's a pretty bad example. I would go 1 plus x over 1 plus 2x plus x squared. And we need to decompose it into smaller fractions. This has a variety of uses. Some of them involving calculus, some of them involving the binomial expansion that we saw in chapter 1. So, how would we decompose a fraction like this? It's very hard to explain if we don't have a problem in front of us, actually, so I'm just going to take the first problem from the exercise and show you what we need to do. So, if we want to have 1 over x squared plus 5x plus 6, and we want to decompose this into smaller fractions, well, first we need to figure out what those smaller fractions would be. So we can get those smaller fractions by factorizing this. Say x plus 2 times x plus 3. And so the smaller fractions would be like a, where a is an integer, over x plus 2, plus b over x plus 3. And you'll notice that, that you can always express this fraction as the sum of other fractions with the numbers constituting of its denominator. And there are a lot harder partial fraction questions, but they aren't asking for them right now. So I will teach you this basic one first, just to make sure that you've got how to do it. So to convert this fraction and to find out what a and b are, we want to multiply all of the fractions on the left and right hand side by this denominator. And what that will give us is, it will give us 1 is equal to a times x plus 3, since the x plus 2 is eliminated by the x plus 2 eliminates the denominator, and similarly b times x plus 2. Okay, and so now we have to equate the coefficients of x. So this, on the right side, this is really equal to 0x plus 1, and so we have 0x is equal to ax plus bx, and 1 is equal to 3a plus 2b, right? So since we know 0 is equal to a plus b, we know that a must equal minus b. And so since 1 is equal to 3a plus 2b, substituting minus b into here, we know 1 is equal to negative b. So b is equal to negative 1, and a is equal to 1. And so therefore, our final answer should be that 1 over x squared plus 5x plus 6 is equal to 1 over x plus 2 minus 1 over x plus 3. And you can check this graphically if you punch this into your graphical calculator. If you graph this side of the equation, and if you graph this side of the equation, they would be the exact same. Okay, so let's move on to the next question. We want to decompose 4x plus 9, 4x minus 9 over x squared minus 3x into partial fractions. So first we want to find out what the partial fractions are, and we know that x squared minus 3x is equal to x times x minus 3. And so our partial fractions would be a something over x plus something over x minus 3. So now multiplying both sides by this denominator, we have 4x minus 9 is equal to a times x minus 3. plus b times x. And so we have 4x is equal to ax plus bx, and often to simplify this, it's written as you just divide all the x's. So you just have 4 is equal to a plus b, and minus 9 is equal to minus 3a. So from this, we know that a must equal 3, and since 4 is a plus b, b must equal 1. So therefore, the answer is 3 over x plus 1 over x minus 3. So we have 3 over x plus 1 over x minus 3, and there it's done. So for the next problem, we have 5 over negative x squared minus x plus 6. And I'd like to move this negative up to the numerator because it will simplify things later. So if we just flip all of these signs around, this would be x squared plus x minus 6, negative 5 over x squared plus x minus 6. And we know that x squared plus x minus 6 would be equal to, well, x plus 3 times x minus 2. So we know that we can simplify this into the form a over x plus 3 plus b over x minus 2. Something like that. And so if we multiply both sides by the denominator, is equal to negative 5 over x is equal to a times x minus 2 plus b times x plus 3. And so we have negative 5 is equal to, we have 0. If we remember, this is 0x here, so we have 0 is equal to a plus b, and negative 5 is equal to negative 2a. Is that a 3? Yeah, sorry. This should be a plus. I just can't write pluses today. Negative 2a plus 3b. So we know a is equal to negative b, and we know negative 5 is negative 2a plus 3b. So we'll substitute b as negative a. So it's negative 2a plus 3 times negative a. So it's equal to negative 5a. So we know a is equal to 1. And since we know from here that b is equal to negative a, b must be negative 1. So if we go back up here, we can see that we got this correct. So if we remove these, we can replace them by 1. 1 times x is 3 minus 1 times x minus 2. Okay. Now on to the final problem of the speedrun. We have 11 plus 3x over 6x squared plus 5x minus 6 is equal to, well, something. We need to figure out what that something is, so first let's factorize this at the bottom. This is actually quite a tricky factorization. Let's see, what would this be? This would be 9 minus 4. Yeah, so this would be 3x plus 5x, so 3x minus 2 times 2x plus 3. I believe, yeah, so 3x times 3 is 9x, minus 4x is 5x. Yeah, so it would be this instead. So we can just simply erase that, and we can put 11 plus 3x over this. And we know it's equal to a over 3x minus 2 plus b over 2x plus 3. And we need to find out what a and b are. Multiplying both sides by this denominator, we get 11 plus 3x is equal to a times 2x plus 3 plus b times 3x minus 2. B times 3x minus 2. And so therefore, we know that 3 is equal to 2a plus 3b, and 11 is equal to 3a minus 2b. So I guess, well, what can we get from here? I would, I mean, yeah, I guess to make it simpler, we can just say b is equal to 3 minus 2a over 3. And so we substitute it in here. 11 is equal to 3a minus 2 times 3 minus 2a over 3. And I'm going to multiply everything by 3 to eliminate this denominator. So we have 33 is equal to 9a minus 2 times 3 minus 2a, which is equal to 9a minus 6 plus 4a. So that's equal to 13a, if I'm not mistaken. So we have 39 is equal to 13a, and therefore a is equal to 3. So a equals 3, and b is equal to, we'll just put it into 11 equals 3a minus 2b. Actually, no, it's just simpler if we just use this. So b is equal to 3 minus 2a over 3. 3 minus 2 times 3 is 6. Is negative 3 divided by 3. B is negative 1. Yeah. So therefore, our final answer is we have 3 over 3x minus 2 minus 1 over 2x plus 3. So yeah, that was it. I hope that you're a bit more confident about partial fractions and all of this. Yeah, it feels a bit weird. So I would highly recommend doing the other exercises in the book to get some practice on it, and I hope to see you in the next speedrun.